G'day ladies and gentlemen, this is our second video relating to uncertainties. So we have a formula that we can relate this to. So the Reynolds number, and we're going to have the P as a constant with 999 kilograms per meters cubed. The viscosity will be a constant, 0.001002 kilograms per meters per second. And then we're going to have values of velocity. So we took several measurements for velocity, and there were 5 measurements, and all of them were relatively similar. However, one value was ridiculously out, so we'd strike that out, and then we calculate the average for that. And the way we would do that, we would sum all the values 1 to 4, and then we would divide it by the 4 values or the sum of the values that they have, and that would give us 1.7225 meters per second. Now the average uncertainty is slightly different. With the average uncertainty, you would find the max value, in this case 1.78, and the minimum value, in this case 1.68, and then we divide that by 2, and we would find that it would give us an uncertainty average of 0.05. Now we would figure out what percentage 0.05 is of 1.7225, and that would give us 1.72 plus or minus 2.9%. So that's our velocity value here. Now the diameter, say, of a sphere was measured by the vernier calipers, and the vernier calipers had an accuracy of plus or minus 5 times 10 to the negative 6 meters, and the diameter that was measured was 5.1 times 10 to the negative 5 meters. Now we'd find what percentage that uncertainty is of 5.1 times 10 to the negative 5. In this case, it'll be plus or minus 9.8%. Now, we are ready to do our calculations. So, our Reynolds number, in this case, would have the constant, 999, our velocity, 1.72, multiplied by our diameter, 5.1 times 10 to the negative 5, and divided by our viscosity. Now the Reynolds number here would be hypothetically 87.46. Now the percentage uncertainty is calculated, as we saw in the previous video. We had 2 values of uncertainties, and when you multiply 2 values with uncertainties, you add those percentages of the uncertainties together. So 9.8 is the uncertainty for the diameter of the sphere, and 2.9 is the uncertainty for the velocity of that sphere, and you would get 12.7%. Now the real uncertainty would be 87.46 multiplied by 12.7 divided by 100. So basically just applying that percentage value, and 12.47 yields a value of 11.107 plus or minus 11.107, which is the uncertainty value. And then applying the rules that we touched on in the previous video, you would round up 87.46, and you would also round up the 11.107. Now, one of the rules says the uncertainty must have one significant digit, However, rounding up to 20 is a little bit much, and I would not round an uncertainty down. And that is the end of the video. Thank you.